Well, welcome, ladies and gentlemen, to Fundamentals of Financial Management. Once again, I'm Dr. Brad Beauvais, and I want to spend the next few minutes kind of walking and talking through some of the fundamental aspects of not only this course, but also the field of financial management. Why are we here? What are we doing? What sort of concepts and material are we really expecting to see during the course of the semester? But also start to impart some of the fundamental tools that really we're going to draw from for the duration of our time together and truthfully well into your professional careers. So first question really we need to address is, what is this thing called finance? And without reading directly off the slide, really finance is a decision science, and really centered on how we acquire and actually put into practical effect the funds that come through any organization, whether that's a not-for-profit hospital, a for-profit technology company, whatever the case may be. And of course, the same concept extends into our personal finance realm, especially as we start talking about investments of any kind, whether that's real estate, a stock, a bond, what have you, as well as into public finance. And we can certainly look at a recent newspaper, the news, whatever. We hear discussions over tax revenues and the deficit, and basically all of the issues that we hear batted around as part of the budgetary discussions up on Capitol Hill. But our primary focus for the purposes of this class is this middle element of corporate finance, and really how organizations, and it doesn't necessarily have to be just a for-profit company, but how organizations both acquire and manage the funds that flow through the organization. So during the course of this semester, we're going to talk about some pretty fundamental concepts within the field of financial management. We're going to start today with the time value of money, why that's important and how that's used. We're going to walk and talk through risk evaluation and analysis, debt and equity financing, the concept of the weighted average cost of capital, and how that is actually employed and used in the capital budgeting process. We will then look at capital budgeting through a risk analysis lens, as different projects, different investments, what have you, come into play or into consideration. We'll also talk through lease versus buy analysis and kind of wrap up our semester through working capital and current asset management. So we're going to start at the very basic level, very fundamental level, with the concept of the time value of money. And I kind of put in parentheses here, this is really content that you should have learned in high school. I think a vast segment of our society would benefit greatly from understanding how the time value of money works, because really this is the foundational element that really forms the basis of how we calculate a car payment, a mortgage payment, how we really look at the issues of compounding as we start to contribute towards a 401k or any sort of savings account, whether that's for college or for retirement. And we'll find also this is how organizations really start to understand how to discount from a future value and understand what a series of cash flows given at some period of time or earned at some future period of time are worth to us today. So first and foremost, we have to understand, we have to go through this time value of money basically calculation process, because as we start to look at any sort of series of cash flows, we have to understand that dollars in some out year, whether that's a year from now, 3 years from now, 5 years from now, are worth a different amount than they are today. And primarily this is driven by inflation. We could also talk about aspects of risk as well. But basically a dollar in hand today is worth more than a dollar received at some point in the future. And that's really, again, that's an inflationary sort of issue. Because of that, we have to adjust any future cash flows to appropriately in order to value all those future cash flows on a present value basis. And there's a good little Investopedia link there that's in your slide deck that will explain this in some further detail. I encourage you to click through. So how do we start this? Well, as basic as it sounds, we start with a timeline. And you can draw it however you want, you can draw it wherever you want, It could be on the back of a napkin, it could be on a cereal box, in Excel, whatever. But really what we have to start to understand is when and how cash flows accrue as part of any sort of project or investment valuation process. And again, as it says on the screen there, a linear representation of potential cash flows. And really what it does for us is helps to crystallize exactly when a cash flow is going to occur. And we can get ourselves into some pretty muddy water if we don't understand when we have to pay certain things, when we can expect payment for certain things, and then appropriately analyze based on time value money concepts. So here's the basic timeline. The cash flow, or the CF0, is considered to be today. Again, CF0 is considered to be today, or whenever we expect the project or the investment to start. And then any future period, 1, 2, 3, could be a month from now, a year from now, or whatever time, basically time frame you want to consider. Okay, so the key is, and I'll explain this a little bit later, but the key is to make sure that that time frame is consistently applied across our timeline. So we can't compare weeks with months, months with years, and so on and so forth. Okay, so time 1, end of period 1. Of course, any inflow is considered a positive cash flow, and any outflows are marked with that negative or minus sign. Okay. I can tell you from personal experience, it's embarrassing when you get up in front of an executive level audience and you suddenly realize that something that should be going in as a negative has been put in as a positive, and that completely disrupts your entire analysis. So one of the things we'll talk about throughout this class is being very, very particular, very, very careful with how cash flows are entered into any sort of finance analysis. Okay, simply missing that one minus sign can throw your analysis off by hundreds, thousands, millions of dollars potentially. Missing a comma, missing the currency valuation, whether that's in dollars, yen, whatever, also very important. And many of you will work in environments where the dollar values are large and the denomination of currency can vary somewhat. So just word to the wise throughout this course and beyond, just be careful about how things are entered. So there's 3 rules to time travel. Didn't realize that this was quantum physics. I know many of you thought maybe you're signing up for a finance class, but we're actually going to talk about time travel, of course, within the financial realm. So first and foremost, I'm kind of reiterating rule number 1 to time travel. Only values at the same point in time can be compared or combined. That means that I can only compare years with years, weeks with weeks, months with months. Okay, we can appropriately adjust the math in order to make that comparable, but we have to make sure that we're on the same sort of time frame. Again, typically we're going to look at years, but due to various characteristics of the project you're considering, you may want to change it to months, may want to change it to weeks or even days. Second rule, anytime you move forward in time, it's called compounding. That should be a familiar term with many. And then you can see the actual mathematical calculation of what we do over there to the right, with the future value at any time period n, whether that's 3 years from now, let's say, the future value in 3 years is our initial capital, C, times 1 plus R to the nth. So R in this case is our interest rate, and n is the number of periods. In our example would be 3. The third rule is moving backward in time, you discount it. And I would argue we use this particular rule probably in finance, at least in my professional experience, more often than anything else. This is just the inverse of our compounding calculation. Here we just put that capital or that cash flow we're expecting to receive at 3, 4, or 5 years in the future. That's in our numerator. In the denominator, we then have our 1 plus R to the nth that I just explained under rule number 2. So that first rule, again, we can only combine or compare values at the same point in time. So an example of this, if I prefer a gift of $1,000 today or $1,210 at a future, or rather, which would I prefer? And without belaboring the point, it really kind of depends, right? Well, it depends on when we talk about in the future. Is that tomorrow, or is that a year from now, 5 years from now, what have you? And another big factor that we're going to talk about frequently in this course is risk. What is the risk factor involved with any particular likelihood of a cash flow accruing in our benefit or a debit of some kind? Second rule of time travel, from a purely mathematical standpoint, we're looking at, for example, if we look back at that $1,000 that we were going to receive in the first rule, and we now compound it, right, by 10% over a 2-year period, we can see that $1,000 today is roughly equivalent to $1,210 2 years from now at 10%. So one could argue that we're essentially ambivalent in terms of which one we received if we set aside the issue of risk. How likely is it that we're going to get paid 2 years from now $1,210? Okay, so again, that's a topic we'll revisit in the future. So that second rule of time travel, again, we can do it long-handed mathematically however many times we need to. So if this is over a 20-year period, you can understand that this, at least from a longhand perspective, would be somewhat laborious. Okay, and I'll skip over this. You can read through the example in the slides, hopefully understand in a little greater detail what that looks like from a purely calculative standpoint. Third rule of time travel, again, is discounting. This is where we find our present value of a future cash flow. Again, as an example, offer an investment that pays $10,000 in 5 years. I expect to earn a 10% return. What's that worth to me today? Well, we can do the simple math and come up with that particular figure of $6,209. So, recapping all three of these rules, again, rule number one, can only compare and combine time values at the same point in time. As we move forward in time, it's called compounding. As we move backward in time, it's called discounting. Okay, now, because we're talking about finance in particular with an organizational setting, you can understand that our cash flows are going to be widely variable, positive and negative over a series of time. So we need to be able to understand how to value a stream of cash flows and come to an appropriate valuation outcome. So of course we can do this mathematically, and we can go through basically the discounting process and find that PV, that present value, which is simply the summation of all of the present values from start to finish, or from 0 to n in this case, using our summation calculation. And again, discounting each one of those appropriately by the right number, or the exponent, in this case of the n, at the appropriate discount rate, or the r, and come up with a summation of all of those values. Of course, that can be done mathematically. But what I'm going to show you here very shortly is how we do this, and how we basically leverage Excel to do a lot of this heavy lifting for us without having to go through the great hoops that you can understand doing, or what the longhand version of this would really entail. So here's an example. Again, I'm not going to belabor this point. You can see how mathematically this would actually play out and how we would have to go through the process. But again, I'm here to make things, and as I stressed, in my introductory section for the class, as we talk about things from a purely functional standpoint, this class really is going to focus on the practical. How do we actually do this, on the job? How can we leverage Microsoft Excel and other tools to help us reach a better organizational decision? So, of course, we can use a regular calculator to go through the mathematical process that I just showed you. We can also use a financial calculator. That's actually how I learned finance when I was going through school. But of course, most practitioners, most professionals across industries use Excel or some version of a spreadsheet program in order to help do a lot of the heavy lifting with the calculations that we have to perform. And even though you can do the longhand calculations at the entry or the early parts of this course, I highly recommend that you become familiar with Excel using some of the tools and models that I'm supplying to you within the course room on Canvas to really help learn and help you to develop these problems and solutions, because as we get into things like capital budgeting, things like risk analysis, things like lease financing, the longhand calculations are incredibly laborious and incredibly difficult, whereas Excel allows us to be much more flexible and much more frankly capable of understanding what a particular project or investment is actually going to do over a period of time. So if just going back to some of the basics here, what if the future value, or what is the future value of $100 due in 3 years if the interest rate's 10%? And note that in some text or readings you'll see R and I substituted for the interest rate. They mean the same thing, so don't be confused as we're kind of walking and talking through the slides, because I'm leveraging content from a couple different sources, so I want to make sure that doesn't confuse anybody. So in this case, we can do the regular calculator solution. We're taking that $100 and of course we're compounding it over a 3-year period. We can do that with the regular calculator, come up to our $133.10. But the easy way is we can go into Excel and go type in any cell equal FV and open a parentheses right here. Type in our rate. In this case it's 10%, and you can enter in a 0.1, or you could actually enter this as a 10% with the percent sign, comma, 3 years, or the number of periods, that's N per is 3. We're skipping over payment at this point. That'll become important when we start talking about bond valuation and annuities, but that payment skipped over, so we just leave that blank. And then we have a present value of $100. That's our initial investment, okay? And then we're not going to use type. Type is going to become important when we start looking at annuities due versus a normal or regular annuity. But in this case, we're not using payment and we're not using type. So we close the parentheses and we come up with that same $133.10. Now, as my arrow here indicates, normally if I'm taking $100 out of my pocket to invest, I want to enter this as a negative 100. That will return a positive $133.10 when I actually come to my calculation. Okay, one or the other is going to be negative. Okay, that's just the way the formula works. And if we're doing this completely appropriately, we want to put a negative in here to get that positive 133.10. Okay, here are the terms that I just described, just for a little bit more detail. And you can see how, again, as we put things in for the payment later on, as we put things in for the type, what that really means. But we will revisit that content in a little while. So what's the present value of $100 due in 3 years if the interest rate's 10%? And again, this is discounting. So that $100 in 3 years, what's it worth to me today at 10%? Okay, again, I can do this mathematically, of course, as we've learned before, but I can also, of course, do it in Excel. Here's my equal. In this case, it's present value, or PV. Open up my parentheses, that same 10% rate, that same number of periods of 3. Again, I skip over the payment. $100 is my future value. Type, again, is skipped over. Close my parentheses, and I get $75.13. Okay. So other cool things we can do in Excel with regards to time value of money is we can start to understand, well, what is the rate I'm earning on any given investment. So here we have an example of an account that will pay $200 after 5 years on each $75 invested. So I deposit $75 in the bank, I get $200 after a 5-year period. Well, what's the implied rate to that? Ends up being a pretty good deal, 22% rate, but it's just simply the equal rate, open parentheses, 5 years. Okay, I'm not entering a payment or not receiving any subsequent payments or making any subsequent payments rather. My present value is negative 75. Those are the dollars I actually put in the bank. My future value is 200. Again, I skip over type, close my parentheses, and I end up with 22%. I can also solve for the time period involved, or the number of periods. Your textbook, I believe, talks about the rule of 72. That's kind of a thumbnail guesstimate of about how long it will take for an investment to double at a given interest rate. So if we do the rule of 72, 72 divided by 20%, you end up with 3.6 years. Again, kind of a thumbnail guess. Well, the N per calculation can get much more specific, exactly the number or the amount of time it will take for that investment to double. So equal N per, open my parentheses, here's my rate, 20%. Again, no payment, so it's 0. Present value is $1 negative. How long does it take to turn into $2? Okay, that's 2. That's my future value. Again, don't use type, close the parentheses, and we end up with a very specific 3.801784. Okay, now I drew this out for a purpose. When we're talking about doing financial calculations, if you have to lift and place any sort of calculation, my recommendation is you take it out to 4 decimal places. Okay, the better option to this is when we start building calculations and start doing things in Excel, is we link cells together, and I'll show you how to do that if you don't know how to do that in Excel. Because this actual, if you think about pi, for example, 3.14, well, 3.14 is where we typically cut it off. As most of us know, pi extends into infinity. If we leave pi or any sort of calculation like pi in Excel, Excel will use the entire number. Okay, which means that our financial calculations end up being very, very precise, or much more precise than if we decide that we're going to cut it off. If we have to lift in place, we take things to 4 decimal points, and in most cases, although not all, within the homeworks in this particular course, in a practical setting, if you take it out to 4 decimal places, generally that's enough granularity, enough clarity for most individuals to understand exactly how much or what the valuation is of any particular calculation. So just word to the wise. Okay, so like I said before, annuities are one of the applications where we can actually use time value money calculations. So a 3-year ordinary annuity versus a 3-year annuity due. And most people associate annuities with retirement. For example, myself, I retired in August of 2015 from the United States Army. By the good grace of the American taxpayer and 20 years of service, I received my first retirement payment basically a month later. Okay, so I retired in August. My first payment comes in September, October, November, and so on. Okay, that's an ordinary annuity, and you see that often in structured settlements. You see that with various different basically payment structures in normal investment annuities and so on and so forth. Okay, now a classic example of an annuity due is when I don't have to wait for that first payment. Okay, so a classic example is the lottery payment. I'm fortunate enough to have the winning ticket for the lottery. I go in and I basically show it to the lottery folks in the office, and I walk out with my first payment. Now this is assuming, of course, I don't take a lump sum. I take the annuity, and again over a period of time, but I walk out with cash on basically at point 0 or day 1 here. Okay, so slightly different valuation structure. One is I'm receiving the payment at the end of the time period. An annuity due means I'm receiving the payment at the beginning of the time period. Okay, so of course I can go through the valuation process. What's the future value of a 3-year ordinary annuity of $100 invested at 10%? And notice here I'm making payments, or payments are moving along consistent with the timeline. So that future value is $331 over a 3-year period at 10%. Now, instead of going through the long, heavy-handed math, I can actually go through and use future value to help me make these calculations. Here, of course, we have the 10% rate, the number of periods, and here's where, for the first time, we employ the payment function of $100. Okay. Now, in this case, we're eliminating or not using present value and type. Okay. So we close the parentheses, and we end up with the same $331.10. Now, if I move the other direction, what's the present value of that same annuity? Well, here, of course, we're discounting, as we've learned before, and the valuation is $248.69. And of course, we can use present value in Excel to do those calculations for us in the same sort of methodology. So what's the future value and present value if the annuity were an annuity due? And notice that $100 that used to be out here, now we've shifted everything to the left, and we have that valuation stream basically starting at 0, 1, and 2. Okay. So what changes? Well, of course, we can do this long-handed, but what we can do instead of, and this is, again, to show how this can actually be linked together, we have the future value calculation, okay, where we have the number of periods, or excuse me, the A4 is our rate, that's the 10%. A2 is the number of periods, and A3 is our payment. Okay, notice it's as a negative. The only thing that changes is there's no future value here, so we skip over it and we enter a 1 that's actually telling us that, or telling the formula that these cash flows are occurring at the beginning of the period. Okay, so with this in mind, this gives us a valuation of the same $364 that we had before. Okay, that essentially is the same sort of calculation. Okay, present value of that same annuity due. Again, we can do it long-handed, or we can actually go through the same present value calculation. Okay, and come to the same exact result, the $273.55. Okay, now another factor that we're going to talk about, or another issue we're going to talk about, is how we make decisions based on use of the present value. And as we're kind of thinking forward a little bit to the capital budgeting sequence that we're going to be encountering a couple weeks from now, present value rule basically helps us to understand, at least from a quantitative standpoint, when we should pursue a project versus when we should not. Okay, so in general, this concept of the net present value is the quantitative assessment of basically the present value of any future benefits, present and future benefits, less the present value of any present and future costs. Okay, so when we conduct a net present value, all that really means is it's just the summation of all the present value valuations across the entire time frame, whether that's 3 years, 5 years, 10 years, 15 years, whatever the case may be, all project cash flows reduced to a present value, or today's basis, or bringing it all back to 0. So when we do this, essentially, again, this allows us to evaluate an investment decision and help us to understand if there's going to be some economic benefit to pursuing that investment, pursuing that project, or whatever the situation might dictate. Okay. Now, because we're talking about the operational environment, all we're doing, and please realize that when we're going through a net present value calculation, we're doing so in order to basically come to an optimal organizational outcome. Okay. All we're finding with the net present value is the economic or the quantifiable decision, okay, or the quantifiable outcome for that project. We may, in some cases, still decide to do the project even if it comes out negative. Okay, we see a lot of this application in healthcare, for example, where it might preserve our not-for-profit status as a charitable enterprise, and thus it helps us to avoid having to pay taxes. It might be organizational or community goodwill, you name it. There's 100 different reasons why we still might pursue a non-viable economic project where we essentially decide that we're going to take the loss for whatever reason. Okay, but in general, we would want to accept those projects that have a positive net present value and reject those that don't. So, and there might kind of bring up the same issue with the question, if it's a loser project today but creates goodwill in the community or preserves a not-for-profit status, might be a reason to change our line of thought there. Okay, this also allows us to choose among alternatives. Okay, so if I have 3 or 4 different vendors that offer the same product or deliver the same service, as we start to kind of map everything out in terms of how much their particular product costs, the different maintenance situations, how much staff training is going to be required, whatever the case may be, this valuation process helps to basically separate the wheat from the chaff. We start talking about potential returns or potential beneficial outcomes for any particular project or investment. Okay, and then at net present value, if we reduce all of those future cash flows to present value terms, helps us to basically compare apples to apples, at least again from a quantifiable basis. So, here, and this is obviously simplified for the purposes of display here, but we have an uneven cash flow stream. Okay, again, we leverage that timeline that we've already talked about. We set up the timeline to be able to capture or better understand when the cash flow is going to occur. So, and realize that a lot of work has already been done to even get us to this point, because this is basically the difference between all the benefits and all the costs within this year, and we're coming up, fortunately in this case, to a positive 100. Out here in time period 4, it's clear that expenses exceed benefits or exceed revenues, and here we have a negative value. Okay, but everything is discounted to present value terms to come up with this $530.09. Okay, now that $530 could be thousands, it could be millions, it could be billions. Okay, but here we understand basically the summation of all of those present values across this 4-year time frame and what it means to us today at a 10% discount rate. Okay, now notice there's no value here for time period 0. Okay, if we have a value here, it is not discounted, okay, because it's already at time period 0. Okay, all the future values out here, the 1, the 2, the 3, the 4, are all discounted as we see here at 10%. If I have a value here, it goes into the calculation at the time period 0 value. Okay, and we'll talk more about that in a little bit. Okay, so how do I do this in Excel? Fortunately, Excel does a lot of the heavy lifting. So instead of present value, I use the Excel formula net present value, or equal NPV. I put in my rate of 10%. I throw in all of my values, okay, and I can either enter them manually like I have done here, or you can go into and just simply, when you're in Excel, as soon as you drop that comma there, you can come over to your series of cash flows and drag across. So these would go in as cell references, which is what I actually recommend versus direct entry. Close my parentheses, hit enter, and I come up with the same valuation as we did over here with the direct calculation. Okay. Now, the net present value will give us a dollar valuation. Okay. What a lot of folks like to do, though, is be able to compare things on a percentage basis. What percent return are we getting? And the term we hear a lot in terms of the percent return is return on investment, ROI. Okay. Now, even though it's used a lot, just if you haven't heard it before, you'll hear it maybe from me first. Return on investment is it is a suboptimal way to evaluate return on any particular project or any particular investment. The real issue is because return on investment, if you think about how it's calculated, that's my total return minus my initial capital outlay over my capital outlay, okay, does not take into factor or does not take into account basically the time value of money, okay? So we want to be able to use a term that basically uses or leverages time value of money concepts to get us a much more accurate assessment of what any particular project or investment will return. So here we've got, I'm going to use an example from basically an MRI investment project or magnetic resonance imaging system, fairly ubiquitous across most hospitals. And we have a series of cash flows. And here all my dollars are in thousands or in Ks. So this initial capital outlay for this particular MRI, all things considered, is $1.5 million. And then I have positive cash flows for the duration of the analysis. Okay, and again, these numbers come from, these are the final net cash flows, NCFs, net cash flows from all revenues less all expenses to net us out to 310, 400, 500, and so on. Of course, my dollar value for the initial capital outlay here, that $1.5 million, comes from vendor quote, any site preparation required, anything that I have to do in order to get this system up and operational. Okay. So, of course, I can go through the valuation process longhand. Okay. Now notice, and you'll hear folks that have not been through financial analysis when they put together a project that they're developing, will consider all of these cash flows from time period 1 out through 4 at their face value. Okay, and it's not necessarily it's understandable how that might occur. Okay. But once you had a course in finance, you understand that we're sitting here today. In this case, it's May 26, 2017. So that's today. Or let's say I'm going to start this project at the beginning of June. Well, this valuation today is different. This dollar today is worth much different than and much more than a dollar value out here in year 4. So while I might use all these at face value, it can seriously exaggerate the returns that I'm actually going to get from this particular project. Okay, so be cautious for those of those folks that develop some sort of financial analysis and don't apply time value money concepts, simply because, and I'll show you here in a second what that really means. So $460,000 is the expected simple dollar return. To answer my own question there, is this a good measure? I would say it is not. Okay, because if we actually do an appropriate discount, okay, based on, and we're going to talk about how we get this discount rate in a future section. We start looking at the weighted average cost of capital, and then we risk adjust that weighted average cost of capital for this organization based on the risk factors for this particular project. 8% is our discount rate, and we notice the huge difference this makes when we start talking about all these face value cash flow streams. That 750 is not 750 anymore. It actually comes to be 551,000. Okay, likewise 500 is 397. So when we add all these up, in again, this time period 0 figure here, this $1.5 million, is not discounted because it's at present value terms already. We can see that 78,000, okay, is much different than our original 460. And again, to answer my own question, a much better, much more accurate measure. Okay, we never want to basically overpromise in anything, and we want to ultimately be conservative in every estimate that we put in front of any sort of decision-making body, whether that's your C-suite executives, whether that's your board, whomever. So I'd much rather be going to the board with a figure like this and these series of cash flows and fully explain how I arrived at them than to show up with this $460,000 figure over here and overpromise and underdeliver when actually it's put into operation. Okay, now how do we do this in Excel? Well, that same calculation we arrived at over here, the 78. We have our series of cash flows lined up from A3 to A7, okay? And we have our discount rate of 8%. So I just simply down here in cell A10, I do an equal NPV. I open my parentheses. My A2 is up here, that's 8%, comma, and notice I've just dragged A4 to A7. Close my parentheses, and then I add in A3. And of course, we add this in because this is already at present value terms. Now note, if you actually did A3 to A7, Excel will still give you an answer. Okay, it is going to be inherently wrong, okay, but it will do the calculation for you. It has no idea what you're, the logic behind what you're doing. It simply does the calculations for you. So you have to know how to use the tool, and in this case A3, we add that back in, and again hit enter, and we end up with that 78,000. Okay. Now the value to being able to do this, to link cells together as we've done in this particular calculation, now we can actually help the organizational decision makers understand the implications of if I have a change in any of my input factors. So let's say my discount rate, I go into my board and I say I'm using an 8% discount rate. Somebody on the board disagrees with it and says, no, that's too high or that's too low. Okay, I can adjust this one cell and everything else auto adjusts. As soon as I hit enter, it will give me a new calculation. Okay, likewise, if I have a change in any of my cash flows, I underestimated my return in year 2. Let's say that becomes $600 or $600,000. Okay, I make that one change, this auto adjusts. Okay, so this becomes incredibly important when we start doing any sort of sensitivity analysis, any sort of risk adjustment for the calculations that we're making. Okay, now that discount rate, okay, that we just talked about, the top of that timeline. In this case, up here, we're using this 8% discount rate. Okay. There's various different theoretical reasons, and you read through the textbook and in this week and in future weeks how we arrive at that. And we hear it termed as basically the opportunity cost rate for the next best alternative or alternative investment of similar risk. In all practical measures, and this is really why we're focusing, or what we're focusing on in this class, that discount rate is simply our weighted average cost of capital, okay? Or basically, and we're going to talk about this later in the course, but weighted average cost of capital across all sources of capital for the organization, and then we risk adjust that weighted average cost of capital based on the specific situation or for this particular project or this particular investment. Okay, and again, don't get wrapped around the axle too much at this point on the concept, because we're going to talk about it a lot more down the road. Okay, that rate does not necessarily depend on the source of the investment funds for each project, although we will talk about a slight nuance to this when we get into the realm of lease financing. Okay, so that weighted average cost of capital, or risk-adjusted weighted average cost of capital, becomes somewhat important. Okay, because basically what we need to be able to understand is what our capital costs us, and from both debt and equity sources, because what we want to be able to do is determine, as we find a percentage return, as I started talking about a little bit earlier, how do they compare? If I can earn a better return than what my capital costs me, of course that means that the project is likely economically viable. And of course the negative or the reverse of that is true as well. So again, to revisit, a positive net present value expected to create value for the investor. A negative net present value means that it's expected to lose value, at least from a quantitative standpoint. Now, if I want to find the percentage return, okay, all I have to do, and really what this is from a very fundamental standpoint, is we can actually play around with that discount rate, okay, until we get this entire valuation process to come out to a net present value of 0. Okay, so we can do this manually. Of course, we can play around with the different numbers and come up with the exact out to whatever digit we need discount rate that makes this happen. Of course, we can also use Excel to help us do that heavy lifting. Okay, and here we use what's called the internal rate of return, or equal IRR. Again, A3 to A7 is my series of cash flows, and in most of your later versions of Excel, you probably do not even need to add this. You'll find as you open up this formula, it'll ask you for a guess. Okay, if you actually go through the math behind this, this is actually, it crosses the x-axis a couple different places, and you're helping the formula to give the one that's most likely closest to zero. But generally, you can just do equal IRR, open your parentheses, basically drag and drop this whole series of cash flows. Notice we use A3 at this point because this is part of our analysis. We want to know what kind of return we're getting off of this $1.5 million investment. So we close that parentheses and hit enter, and we end up with 10%. Okay, so the decision point at this point is, well, because 10% internal rate of return is greater than my 8% weighted average cost of capital, the project is expected to earn or create economic value for the organization. Okay, and that internal rate of return, again, is just the percentage return expected on that particular investment or that particular project over the life of the project that we've evaluated. Okay, now I also want to tell you, internal rate of return and net present value should both indicate whether a project will produce a positive result or not. Okay, they will both point in the same direction. Okay, it may not always seem that way. For example, you can have a negative net present value and the IRR will still be positive, but that IRR, generally in that situation, the IRR will be less than your weighted average cost of capital. So you could have a negative net present value, let's say, of minus 250. The IRR might still be positive, but it'll be below 8%, just to pull numbers out of the air there. Okay, so don't get confused. IRR and NPV will always point in the same direction, of course, so long as you've done your calculations correctly. Now, as we get towards the end of this, we have to understand too that there is the possibility for intra-year compounding. Up to this point, we basically looked at each time period. It doesn't have to necessarily be years, but each time period as a single lump sum. But realize that sometimes we have compounding that occurs intra-year or intra-period, okay, and we have to handle that appropriately. And of course, you can see the implications here. Future value of an investment is often larger. Present value of an investment is often smaller, depending on which way we're taking the analysis. Okay, so if we were to convert something from an annual basis to a semi-annual basis, all we have to do is take our future value at 3 years, okay, at 10%. Our normal calculations here, that 3 becomes a 6 because we actually have 6 periods now going across this timeline. So in order to adjust that future value to 6 periods, of course we've got 6 up here for our N if we're doing our manual calculation. But notice as well, instead of a 10% value across that entire year, let's say, now it's 5% intra-year. So 5% in the first 6 months, 5% in the second 6 months, so on and so forth as we hop along the timeline. Okay, so that 10 in our calculations is cut in half. Okay, and notice we have a slightly larger valuation. Okay, because we're compounding more often. Okay, so if this turned into a quarterly, okay, that 3 years now, we'd end up with basically, 3 times 4 is 12, right? So we'd end up with 12 time periods, okay, because this would be 4, okay, this would be 4, this would be 4, okay, and we'd have to divide that 10 in fourths, so this would be basically 0.025, and then of course this would be 12. Okay, so all we have to do to make these calculations is to just adjust our inputs appropriately so we end up with the appropriate valuation. Okay, last thing, and maybe from this particular section, maybe one of the more valuable tools that, again, something that should be taught in high school is this concept of amortization. Okay, amortization is what helps us to understand what it costs to buy that new car, what it costs for a house payment, whatever the case may be. Okay, and it's truly a life skill. Once you learn how to do it, it's incredibly simple to set up, incredibly valuable to understand. Well, if I make that extra $50 payment on my house note, how much sooner do I end up paying off my house? What do I save in terms of overall interest? And likewise, understanding, as you go into negotiate on a new car, not just taking the finance individual's word for it, exactly what your payment should be, actually knowing what it should be. I will tell you from personal experience, in basically my 20 years of military service, there was at least 2 times, once I learned finance, 2 times where that finance individual in the car dealership was dishonest and was feeding me a number that was not, or basically was inaccurate. Okay, and I will tell you, it becomes an incredibly valuable negotiating point when you actually call them on it. And the best tool you have in any sort of negotiation process is your ability to get up and walk out. But it's all predicated on knowing exactly what the valuation should be based on the input factors that have been provided. So how do we do this? Well, so I want to construct an amortization schedule for a $1,000 10% loan over 3 equal payments. So this is what it would look like. First and foremost, we find out what our payment is. Okay, so here we're talking about an annual payment. Okay, so that annual rate is 10%, 3 periods, present value of $1,000. We don't use future value in type, closing parentheses. We end up with a payment of $402.11. So of course, if you're doing this for a monthly payment, okay, we would take that 10%, of course, divided by 12. Number of periods is multiplied by 12. Okay, so 36 payments over 3 years. Present value, $1,000, stays the same. That's basically the loan amount. Close the parentheses. We'd end up with, of course, a different number here, but that's how you would actually convert it to a monthly payment. But in this case, we're staying with our annual $402.11. So what I've got to be able to find then, the second step to this, is finding the interest for that year 1, which of course is quite simple. $1,000 at 10%, it's $100. So that first year's payment is $402.11. That's the payment I just found, minus my interest of $100. So my $302.11 is what's actually going to go towards the principal in that first year. Okay, and at the end of the first year, I have $1,000 minus my principal payment. I have an ending balance of $697.89. So of course I can just repeat those same steps for years 2 and 3, and I can come up with an amortization table, which I've got here, and I've rounded some of the numbers off, so don't get confused. That that 697, for example, is just rounded up to 698 for presentation purposes. But we can see after I do that first year, that 698 then comes down here in this beginning balance for my second year. Payment stays the same. Okay, that's the same amount that's going to your lending institution, your bank, or whoever you've borrowed from. Okay, this of course would be $69.80, which of course is rounded up here to 70. I'm able to then pay a little bit more towards principal, so that you'll see that balance or that amount goes up during the life of the loan. But after I take $698, okay, minus my principal payment, $332, I end up with $366, which of course then becomes my beginning balance in year 3, and I repeat the process until we get to 0. So at the end, that payment for a $1,000 note over 3 years at 10%, I end up making $1,206 in total payments, $206 in interest to repay that $1,000 principal. Okay. And again, you can do this for a car payment over, let's say, 48 months, 60 months, whatever the case may be. You can do it over a 360-month mortgage. Okay, and if you need help in doing that, it's just instead of 1, 2, 3, you're ended up basically 1 through 360 months. Okay, and we just have to appropriately adjust the table so that we can understand exactly which way the rabbits are running in each particular month. Okay, easy to do. Once it's set up again, now we can start to do some of the calculations of, additional contributions, whatever the case may be. Okay, so I'll leave you with with this particular saying. I think it's been attributed to several different folks, so I can't say it's solely Thomas Friedman or solely John F. Kennedy. But one of the key things and one of the key takeaways I want you to understand from this particular section, and perhaps the course as well, is a vision without resources is a hallucination. You'll find a lot of individuals that will come up with great ideas, a lot of individuals that want to get something funded, but our job here and why we start to employ time value money concepts is we got to understand from decision-making standpoint within the organization what is actually going to bring economic value and economic benefit to the organization. So with that, ladies and gentlemen, once again, thanks for your attention. Welcome to the course, and I look forward to talking with all of you in the weeks to come. Thanks so much.